Okay, so ladies and gentlemen, good morning or good afternoon. This is the last bit of complex number multiplication, division, etc., that we'll be completing as part of our content for term 2. But you will see one more follow-up video which will outline how to conduct all of these operations using a graphics calculator. So, second last video. The aim for this lesson is to understand how to factorize and solve complex polynomials. Now, from your year 10 content, you should already know the quadratic formula. From the quadratic formula, we also know the discriminant. And the discriminant is used to determine whether an equation has 2, 1, or no real solutions. The quadratic formula, it determines the values of the independent variable when the dependent equals 0. And just in case you can't remember, for our discriminant, b squared take 4ac, quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. We also know a few other things. Since I squared is negative 1, we can rewrite a squared plus b squared into a plus b multiplied by a minus b. This gets written into z squared plus a squared equals z plus ai multiplied by z minus ai, or z squared minus ai squared, where z squared plus a squared equals 0. We can use this information to go into our questions. So for example 1, solve the following. First up, z squared plus 16 equals 0, where our imaginary component ai equals 16. So we substitute our values in. Z squared take 16 I squared equals 0. We expand this out to z plus 4i multiplied by z minus 4i equals 0. Therefore, z must be equal to either positive 4i or negative 4i. Basic quadratic for it here. For part B, let me just open this up a bit. 2z squared plus 6 equals 0. Because they share a high common factor of 2, we can divide both of them by 2 to remove this common factor, giving us z squared plus 3 equals 0. We rewrite this. Z squared minus 3i squared equals 0, because remember, negative forms a positive. By moving things around through opposite operation, the square root of z squared is equal to the square root of 3i squared, meaning z is equal to either positive or negative root 3i. Remember, all quadratics can be factorized into this form, or should be able to. This is going to be a bit of a long video, guys, but let's go along to it. So, with example 2, factorize the following. Z squared minus 4z plus 7. For this one, guys, it should be pretty self-explanatory. Pop it into the quadratic formula. Follow all the steps until you get to our answer of 2 plus or minus root 3i. When you're writing our answers, guys, you could happily write z equals 2 plus root 3i or z minus 2 minus root 3i. It's entirely up to you. It is still a correct terminology. Now, just before we get on to the next component here, the roots of a quadratic are their solutions. We can determine the nature based on whether it is real or complex, or whether it is rational or irrational. How we do this is we use the discriminants. So if our discriminant is positive, it's real. If our discriminant is negative, it's complex. And it makes sense because last year when you were factorizing quadratics, obviously if you had to use the formula and you had a negative discriminant, you could not put this into your calculator. It would just come up as error. If your discriminant is a square value, it is a square number, it's rational. And if it's not a square number, it must be irrational. So for example 3, excuse me, what is the nature of 3z squared minus plus 7z minus 6 equals 0? For this one, because it asks us to observe the nature, we use the discriminant formula. We substitute our known values in. We plug them in. It gives us an answer, 121, which is the same as 11 squared. This means that for our discriminant, it is both real and rational. Therefore, if you were to answer this one, the nature of the roots of 0 equals 3z squared plus z squared minus 6 are both real and rational. That's how you answer it. For example 4. Factorize the following. 0 equals 2z squared plus 3z equals negative 2. We use our formula for this one here, the quadratics. We complete the steps and we get our values of either half or negative 2. Therefore, if we wanted to factorize this, we pop it into our brackets here. Z take 0.5, multiply by z plus 2. And also, guys, because our a value or our ax squared value or az squared value is 2, this must mean it also must be multiplied by 2 up the front here. Next one along. Factorize the following. Similar example. 0 equals z squared minus 4z plus 13. Plug this into a formula. We continue on through here. We eventually get to the point where it is 2 plus or minus 3i. Therefore, when we break this down, we know that it's either going to be z is equal to 2 plus 3i or 2 minus 3i. So when we plop these back into our factorized form, instead of writing a and b, or just a single value for a and b, we put in the entire component of what we've got here. So it becomes z minus 2 plus 3i multiplied by z minus 2 minus 3i. And you just remove the interior brackets. Z minus 2 minus 3i multiplied by z minus 2 plus 3i. That is its perfect factorized form. Guys, the next one we're going to look at is something that actually caused me quite a bit of grief a couple of years ago when I was teaching specialist. And potentially, you guys might get it quicker than me. Factorize the following. Z squared plus z plus 3. We pop it into our quadratic formula. It gets to the value z is equal to negative half plus root 11 over 2i, or negative half take root 11 over 2i. You plug them back in. Instead of writing a, you write the entire possibility here. Instead of writing b, the entire possibility here. And as you can see, it expands out until we get to the form z plus a half plus root 11 over 2i multiplied by z plus a half plus root 11 over 2i. There is a different approach to getting this answer. That's the painful side, but I'm not going through it because this makes it so much easier. Final example. Determine a quadratic equation whose roots are triple the roots of 0 plus 0 equals 5z squared plus z minus 2. So first up, guys, we pop in all of our values into our quadratic formula. And it gives us -1 plus root 4i over 10, or root 4the over 10, or -1 take root 4the over 10. Continues on here. Therefore, we need to find the triple root. So therefore, 3 of z. So multiply both possibilities by 3. This becomes -3 plus 3 root 41, or 41, sorry, over 10, or -3 take 3 root 41 over 10. We plug these into our factorized form here. Z plus 3 take 3 root 41 over 10 multiplied by z plus 3 root 40 over 10. This then breaks back into it here. We now expand. We know that z squared plus a plus bz plus the multiplication ab is our expanded form, So we substitute what we know in. We know what a plus b is. It's already here. We know what a times b is here. We substitute, we simplify it down. And it keeps simplifying until we get it into the form z squared plus 3 over 5z plus 18 over 5. Have a pause of this video, guys, so you can actually check it all out. And on that note, ladies and gents, that is the end of the content videos here. Like I said, I will actually go through a video that outlines how to complete complex operations on our graphics calculators, but that'll be for the next one. So good luck with them all, guys, and I'll see you soon.